Okay, so in calculus, we are moving on to something called the chain rule. The reason why we did composite functions first is because they wanted you to see how sometimes one equation can be inside of another equation. And so what we're going to do now is we're going to figure out how to do the derivative of something like that. So in example 1, they want us to find the derivative of x squared plus 1 squared. They want us to find the derivative of that. So let's say that's y is equal to. Up until now, what you would have done if you wanted to find the derivative of that is you would have to expand that out. You'd have to do FOIL with that and then do the derivative of that. The problem becomes, what if that wasn't a 2 up there? What if that was like a 7 up there? You don't want to do x squared plus 1 to the 7th because we did that in Math 12, and remember that involved things like the triangle, right? The who's-he what's it's triangle. I can't think of his name right this second. It'll come to me. So we don't want to do that. So how do I do a derivative of something where there's stuff inside a bracket and that whole thing has an exponent on it? So that's where something called the chain rule comes in. And so if you want to do the derivative of something like this, this is how they show it, and I'm going to explain it. So they say if you have this, where you have an equation inside of another equation, in this case we have a g equation inside an f equation, how they explain it is this. We do the derivative of the f equation and we leave the g equation alone, and then we do the derivative of the g equation. Now that looks really complicated. It isn't as complicated as they make it look though, or at least I don't find it is. What that really means is we're going to do the derivative of what I call the outside and leave the inside alone, and then we'll do the derivative of the inside. So for example, in this one, I would consider the outside to be whatever is outside the brackets. So this exponent, this squared. So how would I do the derivative of something like that? If this was just an x, right? If this wasn't here and I said just do the derivative of the exponent, you would bring this down in front and you would decrease your exponent by 1. Well, that's exactly what you do, and you just leave the inside alone. So I did the derivative of what I refer to as the outside. They refer to it as the F part of the question, the outside of the question. So they brought the 2 down in front, they decreased the exponent by 1, they left the inside alone. Once you've done that, then they say do the derivative of g. Do the derivative of the inside. Well, what would be the derivative of x squared plus 1? That would be 2x. So then you can clean that up a little bit. 2 times 2x is 4x times x squared plus 1. You could actually leave it like that. If you want to get really technical, I suppose you could do this as 4x cubed plus 4x. But really, that way is the most preferred way anyway, all factored out. So that's your derivative. So not so bad. So in example 2, what they do, seem to be out of breath. I don't really know what that is. They give you capital F at x, and don't let that throw you. It can be y, it can be g at x, it can be q at x, it doesn't matter, whatever, is equal to the square root of x squared plus 5x. Now again, I'm not going to leave it as a square root. I'm going to write that in exponential form. I'm going to write that as x squared plus 5x to the 1/2. Okay, so now I can do the derivative of that. The outside is going to be that exponent of 1/2. So if I'm going to do the derivative, I'm going to move the 1/2 down in front, and I'm going to decrease my exponent by 1. So 1/2 minus 1 is -1/2. So I've really done this part, the f prime part, and I left the inside alone. I left that x squared plus 5x alone. Now I do the derivative of the inside, and the derivative of x squared plus 5x would be 2x plus 5. Technically, that is the derivative, but it's not really how they want you to leave it, okay? So we have a fraction 1/2. This has a negative exponent, so it's going to go on the bottom, and 1/2 is really the same as the square root. So the square root of x squared plus 5x. Negative means it's on the bottom, the 1/2 means it's a square root. This has an exponent of +1, so that means it's on the top with the 1, and it's just 2x plus 5. A few people on the chapter 4 test, when they had something like this, they actually tried to put the negative exponent down below this 2. It doesn't go down below this 2, it goes down with the 2 down here, all right? So that's how you would do the exponent on that one. All right, so we've done the easy ones. Sorry. We've done the easy ones. So now we're going to get into ones that are a little bit more complex. And we're really only going to do these two. This is example 3. There's a part A and a part B on page 279. And so the first one is they give us y is equal to x squared plus 5 cubed and times 4x minus 3. And they want us to use the chain rule to determine the slope of the tangent at x is equal to 0. So they want us to find the slope of the tangent, so the derivative, when x is equal to 0. The problem with this is that with this, I'm definitely going to have to do the chain rule, but I'm also multiplying two things together. So not only am I going to have to do the chain rule, I'm also going to have to do the product rule. I have to do the chain rule inside the product rule. Not fun, but true. So remember that the product rule says g f prime plus f g prime. Now f and g are not the same as they would be up here for the chain rule. Think differently, okay? So this whole thing is f, this whole thing is g when we're talking about doing the product rule, all right? When we're doing the chain rule, the cubed is f, the inside is g. They use the same letter for far too many things, so it starts getting confusing. So I'm going to go through this step by step, and you're lucky in a way because this is on video. You can play it as many times as you need to. Unlucky in that I'm not there to specifically answer your questions, but I'm going to try and anticipate anything you would ask. So to do the derivative, I have to do the product rule with this and this. So here's f, here's g. So we leave g alone, which is 4x minus 3. And we do the derivative of x squared plus 5 to the third. But to do that, we have to do the chain rule. The chain rule says first I do the derivative of the exponent. So I take the 3, I move it down in front, I leave the inside alone, and I decrease my derivative by 1. But then I have to do the derivative of the inside, which would be 2x. So here is my g, and all of this is my f prime. In order to do f prime, I had to do the chain rule with it, all right? So now I have to do plus. Leave f alone, so x squared plus 5 cubed, but do the derivative of g. Now the good news with the derivative of g is there is no exponent up here, so it's just 4. So if I wanted to clean this up at all, 2x times 3, that would be 6x. So 3 times 2x is 6x times 4x minus 3, and then times x squared plus 5 squared. So that is if you want cleaned up. Over here, there's really nothing to clean up except that I would probably write the 4 first. No reason for that other than my neuroses. So now that is my derivative. In other words, the slope of the tangent. Now they want me to evaluate this when x is 0. So this is 6 times 0 times 4 times 0 minus 3 times 0 squared plus 5 squared. So this is 0 times negative 3 times 25 plus 4 times 0 squared plus 5 cubed. So this would be 4 times 5 cubed is 125. So that's all 0. 4 times 125 is 500. So the slope of my tangent is 500. So that's just a matter of putting things into your calculator. The big thing here is that I have to do the product rule and the chain rule all together. That's kind of the big takeaway here. So part B, as you would expect, says y is equal to x cubed plus 2 on the top. And of course, it's a fraction. So on the bottom, x squared plus 3x minus 1, all with the exponent of 3. So because we're dividing, this time we have to do the quotient rule. The quotient rule is gf prime minus fg prime all over g squared. But again, within that, we're going to have to do the chain rule. So, and again, we're evaluating the slope of the tangent when x is 0. So, g is the bottom, f is the numerator. So g, leave that alone. So x squared plus 3x minus 1 cubed, left it alone. Do the derivative of f. The derivative of x cubed plus 2 would be 3x squared. Minus, now we leave f alone. So x cubed plus 2. By the way, I'm going to put this all in brackets because I'm subtracting everything from this point on. So x cubed plus 2. Then I have to do the derivative of g. But g has an exponent on the whole thing, so I'm going to have to do the chain rule with that. So first, do the derivative of this exponent. Move it down in front. Leave the inside alone. Decrease my exponent by 1. Then I do the derivative of the inside, which would be 2x plus 3. So I'm subtracting all of that, and that is all over g, which is x squared plus 3x minus 1 cubed. That is all squared. So when you have an exponent on an exponent, think way back to grade 9. When you have an exponent on an exponent, you multiply those, and so that is 3 times 2, which is going to be 2 the 6th. So technically at this point, you could put 0 in. And I think they really kind of do. Yeah, they don't really do much to this. in terms of simplifying it. You could do quite a bit to simplify it, but because they want you to evaluate when x is 0, there really isn't a need to. This would be 0 plus 0 minus 1 cubed, so that would be negative 1, times 3 times 0 squared, so that would be times 0, minus 0 cubed plus 2 would be 2 times 3. 0 plus 0 minus 1 squared would be 1. And 2 times 0 times 3 would be 3. All over 0 plus 0 minus 1 to the 6. So that's 0. 2 times 3 is 6. 6 times 3 is 18, and there's a negative, so that's negative 18. Negative 1 to the 6 is 1, so my slope is negative 18. All right, so again, I will give you a few of those to try, and let me know if you have any problems. If you do, then I will try and make a video on where to go with that. I suspect there will be some questions, not necessarily because you're having a hard time with this first step, but in simplifying, where do you stop simplifying? And again, sometimes I agree with the back of the textbook and sometimes I don't. So if you don't have any questions, I'll be shocked. I'm sort of just expecting that there will be questions. Okay, so we'll talk to you again soon. Let me know how this goes, and we'll figure stuff out from there. All right, talk to you soon.